So in today's video, we're going to go ahead and delve into integrating hyperbolic trigonometric functions. And so previously we took a look at the integral of sine hyperbolic and cosine hyperbolic, and now we're going to go ahead and look at these other hyperbolic trigonometric functions. And so over here, the derivative with respect to x of tangent h of x is equal to secant h squared of x, right? And that's kind of just analogous to the derivative of tangent of x being secant squared. And then that tells us that the integral, the indefinite integral of secant squared hyperbolic of x dx is equal to tangent hyperbolic of x plus c. And then the derivative with respect to x of secant hyperbolic of x is negative secant h of x times tangent h of x, right? And so this is also kind of analogous to the derivative of secant of x, but there is a negative sign here. And then that tells us that the integral of this function is just secant hyperbolic of x plus c. And then cotangent hyperbolic of x, cotangent hyperbolic of x, the derivative of that is equal to negative cosecant hyperbolic squared, again, analogous to the derivative of cotangent. And then you integrate that and you get that being equal to cotangent hyperbolic of x plus c. And then finally, derivative of cosecant hyperbolic is equal to negative cosecant x, or negative cosecant hyperbolic of x times cotangent hyperbolic of x. And then when you take the definite integral of that with respect to x, then that's just going to be equal to cosecant h of x plus c. And so this is just a little bit of a review. In our differential calculus playlist, I did actually cover the derivatives of these hyperbolic trig functions, but now we're just going to go ahead and do a couple of quick examples integrating these different trig functions. So first of all, we're taking the definite integral from 0 to the natural log of 2 of 4 tangent h of x times secant h of x. And so if we go up over here, we can recall that the derivative with respect to x of secant h of x is negative secant hx tangent h of x. And so with that in mind, we can just go ahead and recognize over here the tangent h of x and the secant h of x, and then we have this 4 as a scalar. And if we want it to be negative, we can essentially just bring a negative sign out, and then we'll end up with 0 times the natural log of 2 times negative 4 tangent h of x times secant h of x dx. So that's going to be equal to negative, and then this entire thing over here is just going to become 4 secant h of x, and then we're going to evaluate that from the natural log of 2 to 0, right? And so that's going to be equal to negative, and then secant h of x, we can take the 4 out. Secant h of x is just going to be 1 over cosine hyperbolic, and so that's going to be equal to essentially, if you want, you can say 2 over e to the x plus e to the negative x, right? And so when we evaluate that at the natural log of 2, we'll get, so that's from 0 to ln of 2, we get negative 4 times 2 over e to the natural log of 2 is 2 plus 1/2, and then we're going to subtract that from 2 over e to the 0, which is just 1, plus e to the negative 0, which is also just 1. And so that's negative 4 times 2 over 2 plus 1/2. That's 2 over essentially 5 over 2, if I'm not mistaken. So that's going to be equal to 4 over 5, right? And then this right over here is just going to be equal to 2 over 2, which we can write that, if we would like, as 5 over 5. So negative 4 times 4 over 5 minus 5 over 5, which is just going to be equal to negative 1 over 5. Negative 1 over 5. That's going to just end up being equal to 4 over 5. Let me just fix that. And also let me remove this over here. So 4 over 5, and that is our final answer right over there. So really the most difficult part was honestly just figuring out how to just input natural log of 2 and 0 without causing too much havoc. And then over here we have the indefinite integral of ln of 1 over 7 times cosecant hyperbolic squared of x dx. And so what we can do is we can write this ln of 7 if we would like. We can write this as the negative natural log of 7, right? Because we take this negative 1 as the power of 7, and then it becomes natural log of 1 over 7, and we can just do the opposite of that. We can remove that negative 1 and make it negative ln of 7, and then here we have the cosecant hyperbolic squared of x dx, and then this right over here plus the negative sign, if we want to go up again, we know that that's just going to be equal to the derivative of cotangent hyperbolic, and then we have that natural log of 7, so this just becomes natural log of 7 times cotangent hyperbolic of x, and plus c, of course, because it's a definite or an indefinite integral. And this natural log of 7 is just a scalar, so we don't really have to think about it. And so that will be our final answer. And then finally over here we have the indefinite integral of this very intense looking function. But all we have to do is recognize we have this cosecant h of x, cotangent h of x, we have the negative sign. This 3e to the x, we don't really have to think about it for the moment. And then if we want to go up again, we know that this is just the derivative of cosecant h of x. And so this entire term over here that I'm underlining, this entire term is just going to become 3, and then that's just going to become cosecant hyperbolic of x. And then this plus 3e to the x, we know the integral of e to the x is just e to the x, so this will just become 3e to the x. And then we have the plus c, and so that would be our final answer. So I hope this isn't really too complicated. It's really just about remembering the derivatives of these hyperbolic trig functions and then knowing how to spot them when you're integrating.